right, guys, let's take a look at this. Listen up. So we are using Pascal's triangle to expand binomials. This Pascal guy, he only lived to be, 39 years old, so he didn't have a very long life, but he was a famous French mathematician, and he actually had a lot of contributions to mathematics, even though, he died fairly young. So what happens in Pascal's triangle is he figured out this pattern that always works when we're trying to expand a binomial. Binomial means we have two terms then raised to a power. Anything to the 0 power is 1, so that's where his triangle started. If I have a plus b to the first, that's just going to be 1, 1 as the coefficients. We talked yesterday how if we have a plus b squared, those coefficients are 1, 2, 1, 1, 2, 1. Then when we had it cubed, we saw how it went 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Okay, so we had all of these numbers. Now, here's how he came up with this triangle. He started off with the 1, then he has 1, 1. Then he has this. Where do you think this number came from? Yeah, he added these two numbers and he got 2. Then for this one, we just bring down the 1, we add these two numbers, we get 3, we add these two numbers, we get 3, and we bring down the 1. See the pattern? Bring down the 1, add these two, add these two, add these two, and this one. Do you guys see it? Could you guys now figure out what a plus b to the 6th would be? What this next level of his triangle would be? I want to give you just a few seconds to try to figure out what would this be. Anybody got it? Jeremy, go ahead.
1, 6, 15, 20, 50.
Everybody see it? Bring down the 1, 6, add these two, add these two, add these two, add these two, and get the 1. Okay? So this would be the next level. Now, the way the coefficients would go, watch this now. I would have 1a to the 6th plus 6a to the 5th b plus 15, how would the next one go? A to the what? Look at the pattern. Look at the patterns of these. So it would go 15a to the what? B to the what? Second plus 20 what? A to the third, B to the plus 15, A to the second, B to the fourth, plus 6a, and then b to the what? 5th, and then finally plus what? 1b to the 6th. That's the pattern. Okay? Guys, look at the pattern. All we're doing is we're using the coefficients 1, 6, 15, 20, 15, 6, 1. Now, the exponents rather have to go a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, no a. The b's, no b, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, b to the 5th, b to the 6th. What do you notice about the sum of these exponents on every term? They have to add to be 6. And we're doing a plus b to the 6th power, right? In the 5th row, what do all the exponents add up to equal? 5, okay? So those are some patterns that can help you on this. Now, example 1 was a problem we just did in the warm-ups, and we did it the long way before we understood Pascal's triangle. If I just saw this, and let's pretend I don't have this up above, I want to create my coefficients. So I start with a 1, then it goes 1, 1, then it goes 1, 2, 1, 1, 3, 3, 1. How many more levels do I need to go? One more level. As soon as I see this 4 here, that's how I figure out to the 4th power. 1, 4, 6, 4, 1. Now, I'm going to go kind of slowly writing this out without looking up above. You have to be able to do this on your own. So it's going to go 1a to the 4th plus 4, I take this down by 1, and I bring in the b. I go to my next term. The coefficient is 6. I take the a down by 1, and I bring the b up 1. I go to my next term, 4. I bring the a down by 1 and the b up by 1. And my last term is 1b to the 4th. So once I have this pattern all written out, I have to now determine what's a and b. So what is a in this problem? X. What is b? 3. And now I'm just going to sub it all in. So I'm going to have 1 x to the 4th plus 4 x cubed times 3 plus 6 x squared 3 squared plus 4x 3 cubed plus 1 3 to the 4th. Are there questions on how I got that? Are you seeing the pattern? I went a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, no a. Here's my a, it was x. For the b's, no b, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th. Everybody see it? Really this 2 should be out there, but it doesn't change the answer in any way. All right, now we just simplify it. So we're going to have x to the 4th plus, what's this term going to be, you guys? This is all one term right here. 12x cubed. This is my next term. Always do exponents first and then multiplication. So what are we going to get? 9 times 6 is 54x squared. Here's the next term. I'm going to have to do 3 cubed. What's 3 cubed? 27 times 4, 108 x. And then my last term is 3 to the 4th, which is what? 81. Isn't that the same answer we got as when we did it on the board? Now, because this is so new to you, this probably seems more complicated than the way we did it in the warm-ups. But as you get used to using this, you get faster with it, and you can come up with the answers pretty quickly. This one, I don't know that we need to go through the whole thing and figure it out. We just wrote out what it would be to the 5th power. But what would you have to let a equal in this case? 2x. And what would you have to let b equal? -5. And then you would have to just go in and plug those in, and you're going to end up with 7 terms when you do that. 6 terms, sorry, 6 terms, yes. 6 terms when you finish that. Okay? Rather than doing all of this problem, I want us to do this one. All we have to, this is always on the ACTs too, guys. I tutor people on getting ready for the ACTs and things, and there's usually, on even a practice test, one of these kind of problems. This is meant to slow you down, this kind of problem on the ACT. Can you imagine if you had to write out the whole thing to find out what the 4th term would be if it's in descending order? It would take forever. But look, guys, we're just going to write out Pascal's. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Do the next one. Do the next level. What is it? Okay? Oh, I already did that one, didn't I? Okay. I was like, those numbers seem familiar. That's because I just did it. Okay, so I'm trying to find the fourth term. If I have something to the sixth power, which am I using? Am I using the first row, second row, third? Which one is it going to be? This bottom one right here. Whenever I see that 6, that's the one to the sixth power. So I'm trying to find the fourth term. 1, 2, 3, 4. So I know that my coefficient is going to have to be 20. Now, thinking of the pattern, it would go a to the sixth, a to the fifth, a to the fourth, and what would it be? A to the third. What would b be raised to? To the third. Remember how we said those exponents have to add up to be 6? So all we have to do now is figure out what is a in this problem and what is b in this problem. What's a going to be? 3x. What's b going to be? Negative 2y. You have to take the signs. So to figure out what that fourth term is, I'm going to do 20 times 3x cubed times negative 2y cubed. This is all one term. This is going to be that fourth term if we were to expand this whole thing. It's not subtraction here. It's multiplying by a negative. So we're going to have 20 times what? 27x cubed times what? So is it this times this minus this? No, it's all multiplication. This is the fourth term. 1, 2, 3, 4. The fourth term. So I know this answer is going to be negative. 20 times 27 is 540. I don't know, times 8. Can somebody grab a calculator and tell me what that is? $4,320 x cubed, y cubed, right? That would be that fourth term. Okay, guys, I want you to do two things. The first thing I want you to do is to find the next row that we would use if we have a binomial to the 7th power. So figure out what this row would be first. I'm going to give you about 20 seconds to do that. What's the next row? Grace, do you have it? You are correct. There we go. There's our 7th row. Make sure you've got that. You should have 8 terms there, which we do. Now we're trying to find the 4th term. So we're going to go 1, 2, 3, 4. So what's our coefficient going to be? 35. What is a going to get raised to? A is going to go to the 7, 6, 5, 4. Yep. And then what's our b going to have to go to? Third. What is a? 2xy. What is b? See if you can figure out what that 4th term would be if this was all expanded out. Anybody else get the same answer? Very good. All right, guys. So I am not going to have you do a ton of these. I just want it to be something that you could do. This would make a nice bonus question, like asking you to find the sixth term of a binomial raised to the ninth power, something like that, which would have taken you probably, an hour to do before you knew Pascal's triangle, because you'd have to multiply it all out and everything. Okay? Any questions? You feel like you could find as many rows of this as necessary? You just bring down the one and then you start adding, go down. All right.